Okay, in this short lecture I am going to briefly explain the need of parallel programming. Let me write it here. Introduction to parallel programming. What we are going to study in this short lecture, that we will study the importance of the parallel programming, why we need it, and its different models based on the underlying parallel computing architectures. So first of all, we need to understand the basic concept of parallel programming in comparison to traditional serial programming. In the old era of single processor computing devices, we used to write a computer program that is a set of instructions. Okay, let me draw it here for you. So in the traditional environment, we have a problem and we divide this problem into, we write a program to solve this problem. This program basically a set of instructions. So we have this problem and we write a program for that. This program contains the instructions. Okay, that program comprises of instructions. Different instructions we have, which are serial in nature, all sequence instructions. So this we call instructions. So once we have these instructions and we execute this program that will run as a process in the machine, so this is going to be run sequentially, this in sequence on the available processor. Which is only processor in the CPU environment, in the traditional computing environment. So this instructions is going to be executed in sequence, one by one. Okay, so if the problem is that, so if we have one instruction that uses this processor and another instruction which doesn't use this processor and going to our input and output, so then in that case this processor remain idle and we lost the we basically waste the not properly utilize of this processor. So different techniques used for overcome this problem in traditionally using pipelining and some multitasking environment. We use time sharing concepts. Okay, but that is only that is all for a single processing machine. But in today's era of computing, we have devices with more processing units that allow us to run multiple instructions in a single execution cycle. And for the benefit that we get, the performance, because the doing computing is for performance, and by using the this multiple processing units, we can enhance the performance in terms of instruction throughput. Yes, this is right, that we are not enhancing the speed of the processor, but we are enhancing the execution of the instructions. So in that environment, what we have, where once we have a problem, okay, like we have this problem here. So if we have a problem, okay, so then what we do, we decompose this problem. We have this problem and then we decompose this problem into different independent units, different independent set. We decompose this problem. Okay, like this 1, 2 and 3, 4. So let's say we have this problem, we decompose this problem into 4 different parts, okay, to run it on 4 different processors. So each problem is set each part of the problem should be what it contains. It is basically the set of instructions. So these are the set of instructions for each part. Okay, and similarly if we go further, okay, so then another part, this is another problem, another part of the problem, and we have this set of instructions, okay, which can be more, which can be less, okay, this is possible. So these are different set of instructions for different part of the problem. So in this case, what we do, once we have these decompositions and we have a set of instructions, we run these instructions in parallel on different available processors elements. So we have different processing elements, processing 1, processing 2, we have this, we have different processing elements available here, okay. We run these these instructions on different processors in parallel. So we have these 4 set of instructions, different instructions, we run these 4 set of instructions on different processors, okay. So the first instruction set is goes to the processor 1, okay, the second goes to the processor 2, and the third goes to processor 3. So we have this third goes to processor 3, and the fourth one is goes to processor 4. So let me write it here, this processor 4, okay. So what we get, we have in total this sequence of instructions, and these instructions should be same, but or maybe they are slight difference, but it is running in parallel, so we get more instructions executed in one cycle instead of this. Here we are executing one in sequential computing, we are executing one instruction in one cycle, but in parallel computing we are executing 4 instructions in one cycle. That's the benefit, okay. So in order to fully utilize the modern computing architectures, we have to clearly understand and apply the concept of parallel programming for so we can write an efficient parallel program for a given processor. So this is required some in-depth knowledge about this. And moreover, compared to serial computing, parallel computing is much better suited for modeling, simulating, and understanding complex real-world phenomena. Okay, so what we need to know, so in comparison to serial computing, parallel computing is much better suited for what? It is better suited for modeling, simulating, okay, understanding complex real world problems. Okay, the example we have for these problems, for example, if we want to study and analysis the galaxy formation, that is one of the problem. And if we want to study and analyze the planetary movements, okay, and third one, if we want to analyze the climate change, okay, and if we want to analyze the rush hour traffic. In all of these cases, we have a huge amount of data. That data cannot be processed on single machine. So what we need a high-end parallel computing. Okay, we need a high performing parallel machine. Okay, that is with using parallel programming. Okay, so we cannot utilize the parallel machine without using the concept of parallel programming. So that is the main core idea about the parallel programming.